Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The seventh planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have, friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups: 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These two shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's 5th biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the 7th planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the 3rd largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, Then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see, if you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover.
We also might have just stumbled upon the mother of all water reserves, floating in space. And it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard to even imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our Moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.8 billion miles away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 1.9 billion miles. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird, windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, but these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia, what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks formed down there could also explain why Neptune is hotter than it should be, and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, it's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1 million miles away. Hot environments aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movement inward would have been unstoppable, and it would have also collided with the star. This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools. But every time you step outside, some of it might land in your hair.
I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme, 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth, at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you. Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet, and your bulky spacesuit, you'd run a bit more slowly there, at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature, awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds. And against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer, when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour. That's the end of your active adventure. Which planet did you like running on the most?
The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter, high tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. The planet's disk would look reddish. Make that reddish. And it would be almost twice the Moon's size. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color, very beautiful bluish-green. If either of these planets replace the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions, and probably louse up the internet too. But the most dramatic scenario would happen should the Moon get replaced by, ta-da, the Sun. See for yourself, the distance between Earth and its natural satellite is about 240,000 miles, and there are between 28 and 43 million miles between the Sun and Mercury. Even though this distance is huge, Mercury is a scorched, deserted place. It has enormous temperature differences, from minus 280 at night to 800 degrees during the day. In other words, if the Sun suddenly appeared as close to Earth as the Moon, it would instantly burn everything off the planet's surface. You wouldn't even have a millisecond to wow at a blazing ball of plasma covering the whole sky. Bring your marshmallows. Solar flares are much longer than the Earth's diameter. Just one of them would be enough to melt the planet's crust, burn its atmosphere, and wipe all forms of life off the face of the Earth. So, given that, I'll bet those chores around the house you've been putting off don't seem so bad now, do they?
Why do we look the way we look? Most of it's down to dear old planet Earth. Its atmosphere, gravity, that kind of stuff. When you go on a week-long beach getaway, you get a tan. Basic. But what about living on a whole other planet? One astronaut spent a whole year living on the International Space Station. Zero gravity means no healthy pressure on your body, so his bones got weaker. So did his muscles. It also gave him more space between his vertebrae, so he got a bit taller. And that's only a year. The more time you spend at the beach, the darker your tan gets. So, what if we move to Mars? The first major change you might notice, after a couple hundred years, is your brand new skeleton. Gravity on Mars is much lower than on Earth, so your muscles and bones would probably shrink. not great for surviving on a new planet. Gravity would make us feel our weight differently. If you weighed 150 pounds on Earth, you'd only feel like you weighed about 50 pounds on Mars. You'd need to eat more to get stronger and bigger to make up for Mars's weak gravity. Sweet! Time to grow some larger and stronger bones, organs, muscles, everything. There'd be one more dramatic change. Your largest organ, your skin. It's the most important barrier that protects you from everything. Germs, wind, UV light, looking totally creepy, you name it, it does it. You might just need a whole new skin. How do you feel about orange? Sorry people, green skin is totally sci-fi. Here's the deal. Carotenoids offer quite a nice protection against UV light. That's the stuff you find in carrots, sweet potatoes, bell peppers, tomatoes, pumpkins. A Mars farmer's market could make a fortune. The more of these veggies you eat, the more orange your skin's gonna get. If you followed a special diet and wore high-tech gear, chances are, one day, living on Mars might be totally normal. Living on Mercury would be really tough. It's the closest planet to the Sun, and it's definitely hotter than Earth, but weirdly, not hotter than Venus. It's really hot during the day, about 800 degrees, but at night, it drops to -290. Days on Mercury are kind of crazy. You know, when you finish the day, but you didn't really get a lot done? Problem solved. Move to Mercury. A day on this planet lasts about 58 Earth days. That means you'd have a lot of time to get ready for bed. My guess, though, you'd probably get kind of bored. One excellent solution. Somehow, become made of metal, like titanium, nickel, or platinum. Those guys can handle extreme conditions. Life on Venus would be way worse than Mercury or Mars. Pressure might be a tiny issue. You'd probably have one long, never-ending headache. Standing on Venus is like being 3,000 feet underwater. Oh, and that thing we need every moment of the day? Chocolate. Air? There's not a lot of that floating around on Venus. There's carbon dioxide everywhere, and the planet's surface is completely dry. That means it's gonna be hot. 870 degrees hot. There are a few species on Earth that can survive the boiling point of water, and maybe if they mutated somehow, they'd survive Venus's crazy heat. 266 degrees is the record so far, set by a species of microbes. So get ready for an epic body transformation. Want to live on Venus? You'd probably have to turn into a tiny microbe just to survive. Luckily, Venus's atmosphere has phosphine, which isn't great for humans, but microbes just love it. But since you're not a microbe, not yet anyway, you'd need to wear special gear to control the pressure and feed you air. It's not looking good. Maybe it'd be easier on Jupiter. Yeah! No. It's got no solid land. This planet's made of hydrogen and helium and is known as a gas giant. Unlike Saturn, you'd probably end up just floating around on it. It's like a giant cloud, and if you ever managed to land, it'd be like walking through a super thick fog. Temperatures fluctuate a lot here. It's freezing on the surface, and the atmosphere can be super hot below the surface. We don't really even know. If you lived on Jupiter, there'd be no spoken languages. The gas planet absorbs radio waves, so even if you could speak, no one would hear you anyway. And there'd be no music, so no dance parties. What's the point? People would have to communicate in sign language. Great! But it's not. The atmosphere on Jupiter is wild. All kinds of winds and gas clouds. You probably wouldn't even be able to see anything. So that's not gonna happen. Still, Jupiter is awesome to look at. It's so big that it can fit all the other planets in our solar system inside it, with room to spare. A trip to Saturn will set you back about a decade, and it'd be a big old waste of time. Saturn's mostly made up of layers of gas. It has no solid surface, so farming, building, or any other normal Earth activities are out of the question. Before landing on Saturn itself, You'd probably want to explore those iconic rings around it. You'd fail though, because the rings are made of millions of ice sprinkles floating in space. That's pretty hard to walk on. You might have thought that Saturn was going to be a good fit for you. Some layers of this gas giant sphere actually have quite a nice temperature. If you dive into Saturn, you'll get to a layer with liquid molecules and a cool 32 degrees. That's like northern Canada, Alaska, Sweden, except that you can't walk on it. Anyway, it's only one minor layer, and the rest of the planet is insanely cold. So I guess if you still want to live on Saturn, you've got some work to do. No biggie, you just gotta turn into a snowball or something. What about Uranus? Time is kinda weird on Uranus, so if you're out that way looking for a nice vacation spot, definitely choose this planet. A 2-week getaway on Earth lasts 3 years on Uranus. There's even a sea if you're up for a beach vacation. The only problem is that it's made of ammonia, that gross-smelling stuff they use for cleaning. But watch out where you land. If you get it wrong, you might end up spending a whole year without any sun. How would you change if you had to spend a whole year in the freezing dark Uranus winter? We'd need bigger eyes to see in the dark, plus more of that thicker skin to keep the cold out. We might even develop a new hearing system, like dolphins have. Neptune. It's another gas planet, but scientists think there's probably a dense core inside. If you took the plunge to live on Neptune, you'd probably turn into a space reptile or cosmic fish, endlessly floating around on the surface. Gravity on Neptune is just a little bit stronger than on Earth. Still, it'd be really hard to stay in one place. The wind there is super strong. You'd have to be much heavier to resist it. Time to eat again, woohoo! But this planet's really impossible to live on. Scientists don't even want to send another spacecraft there. Welcome to Pluto. Freezing cold, tiny, and super far away. Doesn't sound too exciting. It's even smaller than our moon. It would be so hard to stay on the planet. No more trampoline parks, people. You'd probably have to build yourself a huge machine that would spin you around, sort of a fake gravity machine. Still, you try spinning around all day, you'd need a brand new nervous system to avoid feeling queasy all the time. But Pluto's not all bad. There's a liquid water ocean beneath the surface, and ice mountains. If you got yourself a highly trained crew and a bunch of expensive gear, and regular supplies from Earth, nah, too much hassle. Spaghettification. Wonder if you can choose your own sauce? It's actually something you might experience if you ever tried to live in a black hole. It's the process of squeezing objects, like you, into long, thin cosmic strips. So, good news, you'll get much taller. Bad news, you'll be thinner than a single human hair.
Uranus has a 22-year-long winter. On a planet like that, if it was habitable, everything would be frozen and covered in ice, white and gray desert all around. People would have to stock up on food and supplies, make extra sturdy buildings and homes, and always wear thick, warm clothes. Finally, transportation would be next to impossible. But thanks to the Sun, each planet in our solar system has unique weather, climate, and seasons. There are several reasons contributing to that. First of all, it's all about how far a planet is from the Sun. If a planet is close, like our neighbor Mercury, it gets a severe sunbath. But if it's far away, like the dwarf planet Pluto, it gets frigid even during summer. Now, think about how fast a planet spins. Planets that take their sweet time to rotate, like Mercury, have super long days and nights. That means one side gets toasty hot when the sun's out and freezing cold when it's dark. Earth is pretty balanced with its moderate spin speed. The atmosphere matters too. A thick atmosphere keeps temperatures from going wild. But if there's almost no atmosphere, things heat up and cool down immensely. The tilt of a planet's axis and the orbit shape are crucial as well. Even on Earth, places near the poles get 6 months of daylight and 6 months of night, And if a planet's path around the Sun is like an oval, it heats up and cools down more than it moves. Now, no two planets are unique. While some have these changes, others don't. Let's start with Mars, our favorite little planet and potentially our future home. It's the fourth wheel in our solar system and has a quirky way of doing seasons. Like Earth, it has 4 of them, although they're roughly twice as long as those on Earth. But this planet has an eccentric egg-shaped orbit. Because of this, its orbital speed varies more. This influences these seasons. Martian winters last about 4 Earth months. They're also much colder than on Earth. Near the poles in winter, temperatures can get down to minus 190 degrees Fahrenheit. One hemisphere grows an ice cap as winter rolls in, snatching about a quarter of the atmosphere as dry ice. Then, in spring, it gives it back. Mars also doesn't have the luxury of massive oceans like Earth to balance out its extreme temperatures. Scientists believe it might have had some of that in its early days, but now all the water is gone. With no water, Mars can hit very low temperatures in winter and hotter summer days. The grand gas giant Saturn has a slightly more tilted axis than Earth. However, despite its elliptical path and tilt, it stays consistently chilly. That's because it's way out there, far from the sun's warmth. Even though it's summer, Saturn remains distant and doesn't get too cozy. It also has a thick atmosphere. The atmosphere on a planet acts like a temperature regulator. If some part gets too hot or cold, the atmosphere gently distributes this temperature across the planet. So, while one side might catch more sunlight during its equinox, the thick air ensures things stay relatively cool. Up high in Saturn's atmosphere, though, it's a different story. Temperatures can swing from seriously chilly in summer to an almost absurd minus 312 degrees Fahrenheit in winter. Uranus is the next planet, the ice giant. With an elliptical orbit and a serious distance from the Sun, it's stuck in a perpetual deep freeze. Its thick atmosphere also keeps temperatures frosty throughout the year. Uranus has a wild tilt, 3 times bigger than Earth's. It's almost lying on its side, and is probably one of the most intense places in our solar system. During Uranus's summer, one pole gets full sun, while the other end faces the deep chill of darkness. In fact, because of its weird tilt and rotation, Uranus is even colder than its more distant neighbor, Neptune. As we mentioned, each season on Uranus lasts around 22 Earth years. That's as close as we get to George Martin's fantasy books. That's because Uranus takes a leisurely 84 years to complete one path around the Sun, so its journey through the year is very slow. The final planet in our solar system is Neptune. It's the most faraway icy giant. It has a tilt almost the same as Earth's and a nearly circular orbit, so it feels like it's supposed to be a bit more balanced. However, this planet maintains a bone-chilling atmosphere with unimaginably low temperatures. That's because Neptune receives only a tiny 0.1% of the sunlight Earth enjoys. On Earth, there's a gradual temperature shift from near to far. On Neptune, because of its circular orbit, there's only one atmosphere taking a spotlight. Unlike its neighbor Uranus, Neptune gets a bit of warmth from its core. But this warmth doesn't help much. The cold is pretty consistent, whether it's winter or summer. But some planets don't bother with traditional seasons. They just imitate them by having different temperature cycles throughout the year. These planets include Mercury, Venus, Mars, and Jupiter. Mercury is the closest planet to the Sun. Mercury is very weird, because one full day-night cycle on that planet equals 176 Earth days. After half a year on Earth, it's finally time for Mercury people to go back home from work. That's because it moves in an egg path. This is also the reason why it has some wild temperature changes. Sometimes it's very close to the Sun, sometimes it's not. At the same time, it has no atmosphere and no protection from the Sun. This results in extremely hot days and extremely cold nights. But that means it has plenty of time to go from scorching hot to freezing cold. When it's farthest, that's Mercury's true winter, or at least how we call it. So if it had seasons, there would only be 2. The next planet is Venus. It's a planet of relentless heat. Forget about seasons. It's just plain hot there all the time. It's super close to the Sun, and its almost circular orbit and tiny tilt of 3 degrees mean temperatures stay pretty steady throughout the year. Even in the supposed winter or the middle of the night, the temperature doesn't dip below 820 degrees Fahrenheit. It also decided to have a weird spin. Venus spins in the same direction as it moves around the Sun. That means the Sun is always right overhead, pouring its entire fiery love on the planet's surface. Venus doesn't really do the seasons like Earth. The closest they have to seasons is 225 days with at least 4 hours of sunlight. This you could call Venus's version of spring and fall. Jupiter, the big guy in our solar system, doesn't bother with the whole seasons drama. It keeps things simple with a tiny tilt of 3 degrees, almost as laid back as Mercury. Plus, its orbit is a close match to a perfect circle, so it doesn't have much variation in sunlight. Also, with a speedy rotation of less than 10 Earth hours, there's no time for the appearance of seasons from long nights. Winter on Jupiter is basically a repeat of any other time of the year. And finally, Pluto, which is still not a planet, but still worth looking at. Pluto resides on the outskirts of our solar system. This little outcast is the definition of cold. The temperatures are around minus 380 degrees Fahrenheit. It has the weirdest orbit, too. Its orbit is very long, elliptical, and tilted. Pluto travels a huge distance from the Sun. That, together with an almost non-existent atmosphere, keeps Pluto in a perpetual cold state. Winters there can get a bit more extreme than average. However, the biggest shift someone stranded on Pluto would notice isn't the temperature, but the Sun's brightness. Always thousands of times fainter than our earthly view. Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on, what Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars?
In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds? They're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the sun. Venus, for example, has a retrograde rotation, which means that the sun rises in the west and sets in the east on that planet. So now, when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. There are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the sun. However, Some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the Sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. Tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth. We can also take the dwarf planet Pluto as an example. It has a strange rotational relationship with its largest moon, Charon. They're tidally locked, which means that they always face each other with the same side. As a result, Pluto and Charon appear to waltz around a common center of gravity, creating a unique dance in space. But the oddities of our solar system don't end there. There are also planets with super fast rotations. While most planets rotate at a fairly sedate pace, some of them are sonic levels fast. Jupiter, for example, rotates once every 9 hours and 56 minutes, which means that it has a day that's less than 10 hours long. That's fast enough to cause the planet to bulge out at its equator. And also, this rapid rotation creates strong bands of winds that can reach speeds of up to 400 miles per hour. And if all this still seems logical and kinda makes sense, then how about chaotic rotations? Yep. Some planets have a rotation that's so irregular and unpredictable that it's known as chaotic rotation. This is often caused by the gravitational influence of nearby moons or other planets. And it's mostly the case with moons and small objects like that. In our solar system, some moons of Pluto, Saturn, and Neptune have chaotic rotation. By the way, the Sun rotates too, just like the planets. However, its rotation is not uniform. The equator rotates faster than the poles. Pretty weird, isn't it? This phenomenon creates a magnetic field that's responsible for phenomena like sunspots and solar flares. But all this raises an interesting topic. Why do planets rotate in the first place? This may sound like a silly question, but can you answer it? The answer might be trickier than you imagine. It all started around 4.5 billion years ago with the formation of our solar system. When it formed, it started as a large cloud of gas and dust. As the cloud began to contract due to its own gravity, it began to spin faster and faster, like a spinning top. This spinning motion caused the cloud to flatten into a disc-like shape. As the cloud continued to contract, the center became denser and hotter, eventually forming the Sun. Meanwhile, the material in the disk began to clump together and form planets. But because the disk was already spinning, this spinning motion was inherited by the planets as they formed. In other words, the planets rotate by inertia. They inherited the spinning motion of the cloud of gas and dust from which they formed. This is known as the conservation of angular momentum. This is the same principle that causes ice skaters to spin faster when they bring their arms in. And that's a wrap on the wacky world of planet rotations. From the lightning-fast spin of Jupiter to the bizarre backwards rotation of Venus, it's clear that our solar system is full of surprises. But thanks to the laws of physics and the gravitational pull of the Sun, these planets continue to spin on, keeping time with the steady beat of the cosmos. Stay tuned.
You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings? Wedding rings? Rings on the tub? She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. Hashtag Earth Rings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing. Everyone to your homes now! This is not a drill! Everyone, head home! You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This Ice Age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon. While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the moon because it reflects the sun's light. Technically, the moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the sun. They reflect sunlight, and that's why we can see them. Given how far away from the sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigeon have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the 2 huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away. and astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now no one can see what is going on. But this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars. And, as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this sky is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There is another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler-22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler-22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet.
There's only one star in our solar system, the Sun. And all the planets orbit this star. But there are also systems where a planet orbits two suns. For example, Kepler-16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see two sunsets and have two shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits three stars at once. The GW Orionis star system is around 1,300 light-years away from our planet. It's composed of three orange rings. They're made of dust and nested inside one another. In the center of this system, you can see three stars. Two of these stars are binary. It means they orbit each other. The third star revolves around them. Scientists have found out that the three rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with two theories. The first theory says the break in these rings occurred because three suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the three-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarii, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least two others. Plenty of star clusters are scattered all over this galaxy. Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, but then they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our Sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms, and now an equally strong space hurricane might have come to Earth. It was a swirling mass of air about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced, and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape.
Mercury gets a bad rap for always being hot, but that's not entirely true. The planet's got no atmosphere, so its temperature swings are wild. When it's facing the sun, it can get up to a blistering 800 degrees Fahrenheit, but when it's turned away, it drops to a frigid minus 290 degrees. The reason for this is that Earth has a cozy atmosphere that keeps our temps in check. Mercury doesn't have that luxury, so it's at the mercy of the sun's rays. But despite all that, Mercury's still worth checking out. It's close to the sun, which makes it a prime spot for studying how solar radiation affects planets. And even though it's not exactly hospitable to life, there are still plenty of mysteries to unravel. Venus is often referred to as the sister planet of Earth. Yeah, many people believe that it's this beautiful and lush planet, just like our home. But boy, are they wrong. In reality, Venus is a total diva. She's got this thick atmosphere that traps heat and causes surface temperatures to reach up to a scorching 864 degrees Fahrenheit. I mean, I get it. Venus wants to stand out and be unique, but she's taken it to a whole new level. She's like that one friend who always has to one-up everyone else. Oh, you think Earth is cool? Well, I'm the only planet that spins clockwise. Beat that. But let's be real here. Venus is just trying too hard. She's got these crazy sulfuric acid clouds that rain down on her surface and make it impossible for anything to survive. It's like she's trying to keep all the attention for herself by making sure no other life forms can exist. And her atmosphere, it's so thick and heavy that it would crush us like a grape. So, yeah, Venus may look pretty from afar with her bright yellowish glow, but don't fall for that. She's a total drama queen who just can't handle sharing the spotlight with anyone else. Anyway, enough about Venus. Let's focus on the real star of the show, Earth. We may not have all the flashy features that Venus has, but at least we're hospitable and welcoming to all forms of life. Plus, we've got pizza. So who needs sulfuric acid clouds anyway? You may think that since we live on this planet, we know it from A to Z, and there is no room for any misconception. Alrighty, then tell me, what shape is Earth? If you say it's round, sorry, but you're not right. So, our planet may look like a ball, but it isn't a perfect one. You see, because of the spinning action, the north and south poles get squished a bit and they're sort of flat. The Earth's wobbling, and other stuff are actually causing it to change shape over time, but it's still roundish. Let's talk about Mars, the red planet that has fascinated humans for centuries. Now, I know we all have this idea that Mars is this habitable planet that we can just pack our bags and move to if Earth becomes uninhabitable. Nope, that's not entirely true. One common misconception about Mars is that it has a breathable atmosphere. While Mars does have an atmosphere, it is much thinner than Earth's and consists mostly of carbon dioxide, making it unsuitable for human life without extensive life support systems. So if you're planning on taking a stroll on the surface of Mars, you better pack your oxygen tanks. But hey, that doesn't mean we should give up on our dreams of colonizing Mars. Who knows? Maybe in a few decades, we'll be able to call Mars our second home. Some people think Jupiter is a solid planet, but let me tell you, that's just a bunch of hot air. Literally. Jupiter is actually a gas giant made up mostly of hydrogen and helium. It's so massive that it doesn't even have a solid surface. I mean, I thought my bed was soft, but floating on a cloud of gas sounds pretty comfy too. Jupiter's atmosphere gradually transitions into its interior, which means it's like a never-ending party in there. Saturn's rings are one of the most fascinating features of the planet. So, a common misconception about Saturn is that its rings are solid. In reality, Saturn's rings are made up of countless small particles of ice and rock that orbit the planet. They stretch out over 174,000 miles from the planet's surface, but are only about 65 feet thick. The particles that make up the rings range in size from tiny specks of dust to large boulders. Scientists believe that the rings were formed from debris left over after the formation of Saturn and its moons. Over time, the particles were pulled in by Saturn's gravity and formed into the beautiful rings we see today. Saturn's rings also have some amazing features, such as gaps and divisions caused by the gravitational pull of nearby moons. There are also waves and spiral patterns that are created by the gravitational interactions between the particles in the rings. Despite their beauty, Saturn's rings are constantly changing. The particles collide with each other, creating new ones and breaking apart others. This means that the rings we see today may look very different in the future. So next time you look up at Saturn and its rings, remember that you're looking at a cosmic snow globe made up of billions of tiny particles floating around the planet. Now, one common misconception about Uranus is that it's a lazy dude who can't even rotate properly. People think it just rolls around on its side all day long, but let me tell you, that's not entirely true. Sure, Uranus does have a tilted axis of rotation, but it still manages to spin in the same direction as most other planets in our solar system. It's like that one friend who always shows up late to the party, but still manages to have a good time and fit in with the crowd. But let's be real, Uranus is still a bit of an oddball. It's the only planet in our solar system that rotates on its side to such a degree. But after all, variety is the spice of life, right? So cheers to Uranus, the planet that refuses to conform to anyone's expectations. Ugh, I wish I had the guts to be like this. Have you ever heard someone say that Neptune is just a blue version of Jupiter or Saturn? Well, let me tell you, that's like saying a banana is just a yellow version of a cucumber. It's not even close. Sure, Neptune and its gas giant buddies share some similarities, but Neptune stands out in the crowd with its beautiful blue hue. It's all thanks to the methane chilling in its atmosphere. By the way, did you know that it's the farthest planet from the Sun? It's so far out there that it takes almost 165 Earth years for it to complete one orbit around the Sun. Talk about taking your sweet time. And let's not forget about its 14 moons. That's right, Neptune has a whole entourage of moons following it around like groupies at a concert. Maybe they're hoping to catch a glimpse of Neptune's famous blue glow. So next time someone tries to tell you that Neptune is just a knockoff version of Jupiter or Saturn, you can confidently correct them and say, "Excuse me, but Neptune is its own unique gas giant with a fancy blue vibe." Did you know that Pluto isn't actually considered a planet anymore? That's right, in 2006, the International Astronomical Union decided to reclassify Pluto as a dwarf planet. So what exactly does that mean? Well, a dwarf planet is a celestial body that orbits the Sun and is big enough to be rounded by its own gravity. But it hasn't cleared its orbit of other debris. It's a common misconception that Pluto is still considered a planet, but the truth is that it's just not big enough to make the cut. Sorry, Pluto. Don't worry though, you may be small, but you're still loved by many. Plus, being a dwarf planet is pretty cool too. You get to hang out with other celestial misfits like Ceres and Haumea. So keep on orbiting, Pluto. We still think you're out of this world.